Já podemos começar uma pequena introdução de vocês, mais ou menos o vosso nome e o que é que vos atraiu a vir a ter esta sessão. Cerveja, já estou a ver. Isso. Antes de mais, há alguém, somos todos nativos em português, certo? Não temos ninguém estrangeiro em... Ok.
Provavelmente mesmo
Inglês?
English não.
havia um rapaz que
É, você ia perguntar para você não entender, né?
Sim, ele, daquelas da RIM, acho que há greve das rodoviárias.
ok.
Ele perguntou depois, ele perguntou se nós íamos gravar e vamos gravar.
Ok.
Não há ninguém contra gravar ou não. Eu também, a princípio, vou só filmar aqui assim este lado, portanto, ninguém aparece no vídeo. Mas pronto, se calhar podíamos começar. Luís.
Vamos começar. Pronto, o meu nome é Luís Franco, trabalho no Banco BPI. Conheci o José há uns tempos quando começámos a implementar Oracle BPMs e ADFs no Banco BPI. Fui, pronto, comecei, apesar de já trabalhaste com a minha mulher também na empresa
Sim,
dela,
sim.
Já que um background
histórico.
Curiosamente. Basicamente, apesar de eu agora não estar tão ligado com o Oracle, entretanto eu afastei-me um bocadinho, estou agora a trabalhar com OutSystems, estou na banca digital do banco. Mas este tema agora com o Open Banking, com as APIs e Microserviços, cada vez mais está a ser um tema também no banco. Já li algumas coisas, tive algumas dúvidas e quando vi isto, salto-me logo aqui a tela, para tenho que ver isto para ver o que é que José vai falar sobre isto.
Muito bem. Muito obrigado. Já agora?
O meu nome é António Rosário, eu sou novo na programação, comecei a programar desde 2014.
Novo. 4 anos de experiência já não é?
Não, mas comecei do zero. E pronto, e para além de tudo é uma coisa que é acessório, faço só quando tenho tempo livre.
Ok.
Pronto, trabalho em informática, na área em ERPs, com SAS, faço isso há muito tempo e em 2014 tive um tempinho de sobra, algumas formações, li bastante e comecei a fazer algumas coisas. Estou aqui como curioso.
Muito bem.
Pedro, ainda não me conhecem pelo apelido, e vim aqui pela publicidade do Zé, principalmente, que é um bom orador. E microserviços está na moda, a pessoa tem de aprender sobre tudo e o que me interessa mesmo é como é que isso se vai projetar na cloud, a arquitetura.
Muito bem. Renan?
Meu nome é Renan, estou há 3 semanas em Portugal, vim trabalhar na Link, já trabalho com Oracle há 7 anos e conhecimento nunca é demais, né? Surgiu essa oportunidade de conhecer um pouco mais, também ter a companhia do novo amigo de equipe e vamos aprender e ver o que ele tem para proporcionar para a gente, que isso a gente sabe que vai ser legal.
Ok.
Pedro, estou aqui para ouvir um bocadinho o Zé também, perceber o que é que vem da cloud, das Experiências e a própria arquitetura, que vai ser tudo a cloud. Estou neste mundo também há relativamente pouco tempo, sou um júnior ainda. Sim. E pronto, por isso, tudo o que vier eu tenho que aprender estas coisas, é a minha área, é isto que eu gosto, por isso.
Muito bem.
O Gonçalo, estou da empresa Farmax, empresa de ensino veterinário,
Ok.
formação de veterinário. Nós lá estamos a desenvolver um projeto, uma loja online, e que estamos baseados em cima de microserviços.
Muito bem.
Eu estou a fazer sou arquiteto dessa plataforma.
Então encaixa aqui bem.
E vim ver o que é que estavam aqui a fazer.
Muito
Se
bem.
estou a fazer muitas engenheiros ou não.
Nelson,
Obrigado.
trabalho na Pipeline, é um software de vendas, basicamente controle de fluxo de vendas. Nós já utilizamos microserviços e tenho também um bocado de ver como é que se distingue ou que diferenças encontro aqui das propostas que são feitas do que nós fazemos.
Muito bem.
Sou o Ricardo e trabalho bem com o mesmo intuito da nossa.
perspectiva.
Muito bem.
Sou Vitor, trabalho na Exis Tecnologia, a empresa minha short. Sou software engineer, principalmente back-end. Trabalho com Java já há 5 anos, fora a faculdade, né? É principalmente isso. Considero-me um especialista em Spring, pronto.
Muito bem. Portanto, Java, Spring, microserviços ainda não? Sim?
Sim.
Já?
Estou no cliente que eu tenho na Exis, trabalhamos com microserviços. Sim.
Ok.
Provavelmente não da forma mais correta, mas veremos.
Não há uma forma correta. Há uma...
Sim.
Uma ideia.
Sim, há algumas ideias associadas, mas já vamos aí assim, porque estou curioso, sobretudo nas pessoas que estão a trabalhar com Java, qual é o caminho que estão a fazer, não é? Para abarcar aquilo que é o Java Enterprise e agarrar numa coisa um bocadinho mais leve.
Eu só posso usar o Drop Wizard.
Drop Wizard. Também já...
Eu Spring tenho alguma alergia a Spring.
Aí, meu Deus, já temos aqui assim algum combate. Muito bem, força.
Apesar de ter trabalhado muito com ele, mas fiquei um bocado alérgico.
Muito bem. Então depois vamos, no final, nós temos uma... Eu vou apresentar aquilo que é o tema do próximo Meetup, que vai tocar precisamente na questão dos microserviços sobre Java. Mas também não quero desvendar muita coisa antes do tempo. Já agora?
Meu nome é Rui, também trabalho na Exis e vim para utilizar.
Boa, boa. Francisco,
Eu
quem és
sou o
tu?
Francisco, sou responsável da unidade local e vim porque esta área de microserviços é uma área no centro, na escola, e também pusemos ao vivo.
Já me estragaste a deixa. Já não posso dar isso.
Se calhar vamos... Sim.
Is it gonna be in Portuguese?
Okay, we can switch to English. Is everybody okay with it? Yeah? Let's switch to English. Introduce yourself and just state your name and why did you come to...
Well, it's a meetup about microservices, right?
Yes.
Well, I'm in Lisbon for a few days, and I was looking for something interesting to do in Lisbon. And since I'm working I work in Belgium.
Okay.
We're working on the transformation of a monolith to a microservice, and so it might
Great.
be interesting.
Okay, so...
Which company?
Well, it's a Belgian company about healthcare. So
Yeah, okay. So you're here on vacation and you just thought, well, let's just...
I'm here on a
Okay.
city trip, so
I don't think it's to do here in Lisbon. Well, today is not a good day to go
It's
out.
raining, so let's just go to a presentation of microservices.
But yeah, it's rain. It's kind of hard to do.
Perfect. Julian?
Julian, hi. I work in Link, so I came because of José mainly. I like to hear his presentations. More seriously, my background is on integration side, so obviously I'm interested in microservices also. That's why I'm here.
Okay.
My name is Igor. I'm working at Além.
Yeah, okay.
Work as Java developer, and I work there.
Okay. Okay, yeah. So we got a few Brazilians here. Nice. No. Next.
Hi, I'm Hugo. I work with out systems at Cotec. And
Okay.
I'm interested to see how microservices and out systems can integrate
Okay.
in large scale applications.
Okay. Cool.
Hi, my name is Andrew. I'm from Link, working at Cosec without systems
Okay.
right now, and I'm just curious about microservices since it's a buzzword.
Okay. Buzzword. Nice.
Hello, my name is Bernardo Reis. I'm currently working at Capgemini in front-end development with Oracle JS. here. I'm curious about microservices as well.
Okay, thanks.
My name is Carlos Santos. I'm a software architect at Capgemini, and I'm here to tell you about the difference of microservices on premises with to the cloud or else. What is different?
Okay. Okay.
My name is Elder. I work in Além.
Okay.
And I'm just curious about
Microservices. Okay.
My name is Carlos. I work at Morpheus. We're a software company that works on modernizing legacy systems.
Okay, so
And cloud and microservices are what clients are asking for today.
Okay, yeah.
And we're trying to evaluate what fits into our future roadmaps in terms of how we fit microservices into that
Okay.
our solution.
Okay.
I'm Bruno. I'm with Carlos, so everything is said.
Okay.
Hi, I'm João. I'm working at Capgemini, and I'm curious to see what is your approach to microservice architecture.
Okay. So, hands up to who is currently working using microservice architectures. So, few. Okay. So a few, like maybe 30% of the audience. Okay. So this meetup is based on project that Link participated in. 5 other companies also participated, and we built small web shop as an open source project to test and to evaluate what it means or what it should mean to implement a microservice architecture if you want to build something cloud native. Okay, so this was created in March. We did a presentation at a big Oracle conference in March. Then we did it again at Open World, and again, like last week, at the German Oracle User Group big conference, Doha. Okay? So, just to give you an idea, we were 6 mainly working within this project. The team is separated. Some in the UK, some in the Netherlands, some in Switzerland, Germany, and a guy from Portugal also. And this was one of the main issues because we were all working at different times. Some of us were like early birds. Some of us were like night owls, and we were like late. So this posed the first big challenge, and we'll address also this because the actual presentation will be on business aspects, organization aspects, and technical aspects. Okay, so basically this is the web shop that we created. I'll post the presentation slides, and you'll have all of the GitHub repositories there, and also the link for this like small web shop. Each one of us worked on a different area of the application, and basically, this is like a generic web shop. So you have a product catalog, and you have like your shopping cart. You have some loyalty status points. So if you buy a lot, you get more points and discounts associated with it. You get also some finance information like invoicing and so on. And we decided to build this independently. So each one of these domains or bounded contexts, as most of the guys working with microservices state, each microservice should refer to a bounded context. So each one of these handled a specific concept. Okay. Now, some of them had a representation in the portal, so they have front ends. Some of them don't, like the logistics one. So the logistics microservice doesn't have any visual interface, just do stuff like back-end logic. Okay, so this is the overall architecture. We will focus on or instantiate on Oracle specific technology because that's what we did here, but the general principles are applied to any kind of stack. Okay? So typically, each one of us implemented one of these microservices using whatever stack we wanted. So we have some Node.js, MongoDB, containers, then running on Kubernetes, Spring Boot instead of Node, Oracle database instead of Mongo, some Elasticsearch over there also, serverless functions. I mean, you name it. One of the best things about using microservices is the idea of the isolation. So microservices only work when you work with standards. So you have communication standards, and whatever you do inside your microservice is your own responsibility. You can implement it in Java, JavaScript, Go, .NET, COBOL, I mean, whatever you want. As long as you implement interfaces with a specific contract that the other microservices can somehow use or at least consume from a given message hub. Okay? So basically, this is what we did. Even the front end is somehow also implemented as a microservice. This gets into the concept of micro front ends, which is a too complex subject to approach in this presentation. So we're going to have one specifically about micro front ends. Basically, what microservices state, or the idea of microservices, is that for each specific context, you handle everything. The business logic, the data associated with that logic, and hopefully also the UI. And you can handle it like in a separated, isolated container, not container as in Docker container, but like conceptually contained. And the idea is that people who work on a given microservice, they need to understand what happens. And they do from the data to the logic to the actual visual representation. Okay? There's a typical saying that in a microservice, you build it, you run it. So you're responsible for everything, even the operations. Now, this is a big difference in organization because a lot of the organizations and companies, they have people that dedicated to support. Then they have like your development teams and so on. But that's not the idea behind the microservices. So each team should guarantee both the development, the requirements gathering also, but the development, testing, and then the actual operation. Okay? So you should have at least a few basic blocks when you're doing microservices. So typically you should have like somehow a front end, which can be made out of a single UI, for instance. You can have like a monolith for the actual UI, or you can have separated micro front ends that you mash up, and you can do it like through iframes or through portlets, web components, whatever you want. Okay. And then you have like an API here, an API platform, which you will use to communicate between microservices. And there's also, if you noticed here, an event hub. So like a message queue or a message platform. And this is also used to communicate things. Now, a lot of people, they think that most of the communication between microservices should come from the API platform. This is something I do not agree with. I think that most of the communications should occur through the event hub. There's a simple reason for this. If you use the API platform, when you try to invoke something from this to this, as this is a synchronous call, you have a coupling. If this system is down, you cannot execute your logic. Okay? If you use messages, you have a way to not be coupled. So you will consume the messages and the information coming from the other microservices through this event hub. And this is an asynchronous communication. So this is what allows you to handle fault scenarios, where you have like one or two of these down, but you can still operate your web shop. For instance, if you have like your loyalty system, your loyalty microservice is down, you can still go into your web shop, you browse your products, you place them in your shopping cart, you pay the shopping cart, and it will go send the invoice to the finance part. Later, when this is up again, it will pick up the missing messages from the event hub, and it will reconstruct the state. Okay? I just want to spend a few more minutes here and then I'll move on. The idea behind microservices also implies that each microservice has its own data. Now, if you think of it, what does that mean? Does it mean that each one of these microservices should have their own database? Or, I mean, how can you make it? How, in a big system, like with 50 or 60 microservices, are you really going to have one database instance for each one of these? You can, and a few companies do, typically not using commercial products, because each one of the microservices will then end up paying a license. A lot of people are using MongoDB for this, as most of the information that you need from other microservices is not like really complex stuff. You just need to store some data. And this will allow you, if you want to, run a single instance, single database instance per microservice. This will also benefit the idea of resilience. So I can have this specific database down, but this one is up, and this one is up, and so I'm good with those specific ones. Okay? And these are the main ideas that I wanted to highlight. There is one specific here, which is the event schema registry, but I'll get into that further on. So I'm just going to paste here an idea for a modern architecture that was proposed by several companies. It's called OMISA. And it tries to set up the foundations for modern applications. And by modern we mean like what we're seeing like highly scalable, web-based applications. Okay, you can get this also from. We're gonna post it on Meetup, so you don't have to take notes or anything. Okay. So the main idea here, or one of the main ideas here, is that you need to try and implement as much as possible fully decoupled, and in the cases that you actually cannot do it fully decoupled, at least semi-decoupled. Okay. If you go into this website, there's a thorough explanation of the ideas behind the architecture. We just like to show it. We also promote the OMISA. Yeah, I mean, it's just a simple reference architecture. So in here, you can see all of what you need to somehow take into account when you're building modern applications. Things like service stability with the implementation of bulkheads or circuit breakers and so on. It's nice to have something like this so that you can just check, we're building this and we need to implement this in this specific feature. Okay. So the idea behind why choosing microservices, we have web shops since forever. Not really. Since 1990s or something. Why should we do it using a microservice architecture? So one of the most important and key things is the flexibility, and then the second one is scalability. Flexibility in the way that you build things. You can choose your own stack that responds better to your own requirements. Maybe it's just a case that, well, the 3 or 4 guys who are going to implement this, they're really good at Go. So why would you force them to implement it in Java or .NET? Doesn't make any sense. The scalability is tied with the decoupling. So when you decouple things, you can scale horizontally. If they're not tied to anything, you can just create a new instance, you do an ingress load balancer, for instance, and you have 2 or 3 or 4, 10 or 15 instances all serving the same requests. Okay? If things are tightly coupled, you need to scale the full amount of things. So this is what you have when you have monoliths. When you need more power, either you increase the iron running it, or you need to get a new instance which has everything, and not just that single thing that you need to scale. This is very common when you have, for instance, ERPs. So imagine that you want to scale because you get a large influx during Christmas season of customers and orders. So these are the 2 components that need to scale. But if you're running on a monolith, you have to pick it up everything, and then you just multiply everything. So in terms of also on operating costs, if you do it with microservices, it's much cheaper. Okay. The idea of being fault tolerant and robust. So if one microservice is down, you can still operate within the capabilities of the ones which are up. Okay. And you get benefits from technological innovation without a significant impact on risk. This means that you can, for instance, do a patch upgrade on one of your microservices, it's a platform, or you want to change from Java 8 to 10, and you're welcome to. But you contain that change within that specific microservice and not replicate that to the whole system. The decoupled development, of course, yeah, I'm just going to skip this. So you know, there's this guideline, like the 12 factors to implement microservice architectures and cloud native applications. So these are just a few things that you need to somehow guarantee. Of course, you know, stateless, so that you can get or horizontal scaling, REST APIs. You cannot implement microservices. I mean, really implement microservices if you don't have things like continuous integration, continuous delivery. Just it doesn't work. So you need to set up this first. Okay? And of course, the idea of publishing and consuming events, and each microservice is responsible for its own data, and run this through. Okay? So, we've seen this in a few companies when they try to adopt microservices. So the idea is, well, which microservices should be built, and how do we split them within a given domain? There is no like specific rule or anyone that's going to tell you you're going to split it exactly like this. But sometimes you spend months trying to decide how you're going to split it. So the idea is you should not take more than a day to define these boundaries, and then you just like continuously analyze and then evolve. Because splitting a microservice or merging a microservice is something that is not that complicated. You're only dealing with small portions of your code. So if you want later to actually merge them together or just split them because it makes more sense, you can do it. Do not overthink it and spend like weeks trying to decide, oh, but we should like cut the customers and the orders and this and that. Okay? There are a few things that you should take into account. Who is the business owner for this specific domains? How is the organization modeled? Technologies. Oh, but we should, if we do this in a different technology, it will be like 10 times faster. Well, then just split it. Okay? And so on. So merging. The question is, how did we agree with the technology platform? And I've already mentioned we didn't. So each one of us just built it as we wanted to. Another thing that is important is the organizational aspect. So the DevOps thing, get it running, CI/CD, and not only that. Okay. There's also a cultural change. And we're seeing this also in a lot of big companies throughout Europe, even in banking, for instance, where they have like these initiatives where you just go and you try something, and if you fail, well, tough, but we try to do it like in another way. So this idea of failing fast and have deliveries like each week or every 2 weeks, something that is changing. So people are pushing for faster development, and so they're willing to try out things and embrace the failure. If you went to certain sectors in our country, if you would like get into a customer and say, well, we're just going to try it, and if we fail, well, tough. They would pick you up and throw you out of the door, because there was this idea that the IT systems need to be perfect. And I think that things slowly changed, and now we're like trying to put more things out there as fast as possible. Doesn't matter. Just the idea of dedicated ownership. Okay. So if you build it, you run it, you're fully responsible. Your team is fully responsible for a given microservice. for the entire life cycle. We're going to get into a few Q&As along the way to ask how you're actually dealing with it, if you're already building some microservices. Just going to give you a quick overview. We did the estimation for our own web shop thing. We used Oracle, but again, it doesn't matter, just to prove a point. If you build a basic microservice architecture landscape, you have your API platform, you have your event hub, like your messaging, and then you have your VMs, containers, whatever you want. So this is the basic thing. And if you want to add new VMs, you just have to pay this additional cost here. So this is very important, because sometimes a few of us will require some specific technology. And in that case, as it was my case, I built it with using like Oracle Database Cloud Service. I couldn't use Mongo, but I choose to use DBCS as I thought it represent better the idea behind Oracle. But this came at a cost. So whenever a person decides the stack that is going to use on a microservice, they need to take this into account also. How much is it going to cost, and why am I using this specific tech and not another one? Pretty valid reasons. For instance, I never worked with Mongo. I worked, with some degree of proficiency with Oracle DB, so I just choose it based on technology knowledge. But I'm paying the price. Just for my Oracle database, I'm paying $835 per month. The total cost is like $942 for one single microservice. In here, the company has already set up the basic, and each microservice only costs $181. So these are all things that you need to take into account. Next, so these are the considerations behind the operating costs, auto scalability, serverless functions, and so on. Actually, we're doing a project now which is not purely microservice, but it has most of the backend built like that way. But instead of using containers, it uses serverless functions. And the amount of costs associated with it dropped significantly, because I no longer have to have a VM or a container running 24/7. I'm just using the functions as my customers request me. So typically, I will not have that many requests, like from 10 p.m. until 8 a.m. So I pay basically nothing during that period. And then if I had more requests, I pay more. But if I have less requests, I pay less. So it's something that you need to take into account when you're building your application. Shorter developments, I'm just going to skip it through. So the idea behind the user interface, you can have a monolithic UI, and a lot of companies still use this approach. They just build like your UI, and then they invoke through the API. They invoke the services to get the results, and then they build the UI on the monolith. Okay. Then you have this composite UI, which basically has microservices which represent also the actual part of the UI. So this is like the micro front-end approach. And you can do this with iframes, which is the easiest way, but the dirtiest way also. You don't have like CEO, you don't have like SEO, not SEO. SEO, you don't have you have issues with security also. So, I mean, if you really need to, you can do it, but you shouldn't. Of course, our favorite approach is the use of web components, but you need to take into account that neither the HTML5 standard is final, it's still in draft after I don't know how many years, and definitely the web component standard is not defined and final. So there are a few things regarding web components. One of the aspects or categories is to use HTML imports. For instance, Firefox has already said that it will never support HTML imports. So if you're trying to build web components, then use them through HTML imports, you will definitely have a problem with Firefox. And there are a few more issues like that. Okay. Again, we're trying to have a full session, probably hands-on, only for this part. So, regarding the, of course, the even if you use iframes as we did here, so we went for the dirty solution. You communicate through iframes using events, so web browser events. But you really shouldn't. So this is like, don't. Okay. The team doesn't matter. A few guys there. Each one of us handled a different microservice, and so just that you have the idea of the tech stack that we used even a few more, but it didn't fit the slide. So you have a lot of things that you can use. You're not limiting anyone, and you're really taking advantage of the knowledge within your own teams. Okay. Now, when you try to build microservices, a lot of people say, well, let's try and build the API first. So you go with the API first approach. You start to design your APIs. And we also did this. It was not long before we understood that it wasn't really the way to go. So we switched to another communication vehicle, let's call it like this, which is to use events. So we don't use events for everything. We use events for a lot of things. When we don't specifically need a synchronous call, or synchronous integration, we just go with the events. Only if we need specifically a synchronous response, we go with either a command or a query through the APIs. Okay? So let's just go through this. So we have our shop microservice. There's an order requested event. That order microservice there is listening to this event. It does its logic. It says that this order has been confirmed, and then this stock microservice updates accordingly. Okay? So we have like it. First rule is building microservice architectures is not the most easy thing to do, because you're dealing a lot with event-driven architectures. So when you have event-driven architectures, you're entering into a realm of pain, because you're starting to lose the idea of sequence within your actions. So that's why if you're trying to implement something like a transaction using only events, I mean, you're you're in a lot of pain, definitely. So there are a few patterns that you can do, like sagas, for instance. But then you need to build all of the logic behind the compensation. So if we went through this flow here, what happened if someone cancelled, or if the payment gateway written an error in the end? So you need to roll back everything that you did in all of these microservices. And you need to do it in a specific order, so that data isn't inconsistent, or at least not for very long. Okay? So when we tried to build this, we designed first our events. So each responsible for a microservice, they decided what events they needed to consume and what events they would produce. Then we arranged something in the middle. So we defined which events and the actual structure, so the data structure behind it. And after we defined this, then and only then, we started working on the APIs. So we used Kafka for this. Kafka is, it's widespread throughout the world. It's becoming like almost the de facto standard for message queues and handling this type of events. We have a few friends here who work with RabbitMQ, which can also be used for the same thing. In Kafka, you have the opportunity to actually do a rewind and replay, because all of the events, they just stick there. And you can say, well, replay all of the events since spot A in my queue, and it can reconstruct what has happened before. Okay. Avro and schema registry. So of course we use JSON to do most of the communication, but or at least some JSON form. But we ended up using Apache Avro, which I like to think of as an XSD for JSON. You define your schemas, you define the rules of validation, and then you publish those schemas in a schema registry. And when you're consuming data from there, it's automatically doing things like validation, if that message is valid or not. It also does very well schema versioning. So if you have an update on your schema, it's if the change is doesn't conflict with the previous version, it updates those versions, and then the actual consumers can handle this version change. Okay, so this is also very good. As I said, then we go into the API design first, where you start to build your APIs. Okay. We used like Apiary for this. We could also use like Swagger, Open API now, I think it's called. And based on those mock services, so we built mock services, and then from those mock services we started building the Oracle Jet UI. You don't need to actually implement the services behind this. You just need the mock-ups so that the UI part can be designed. Then you build your backend service. You tested it. A lot of people use Red, which is very good also. And then you package and deploy. How many of you know Worker? How many of you know Jenkins? Hey! So Worker is a pipeline tool also. How many of you know Spinnaker? Okay. So also, I mean, Spinnaker, I think it's a little bit more than just a pipeline tool, but it can also work with as a pipeline tool. So you just build it like continuous integration, continuous delivery, continuous deployment in some cases also. So no human intervention. I mean, that's the only way that you can do like multiple deploys each day. So all of the big ones are doing it. And of course also like continuous testing. Okay, so that things don't break up. Okay. So there's this idea of choreography versus orchestration. So should you orchestrate? Should you choreograph the advantages or the disadvantages of doing one or the other? So choreography allows you to have a more decoupled approach, where everyone just waits for given events and they act upon them. They don't stay or need to have like a given set of steps or a given set of sequence. So we typically use choreography based on events for our microservices, and if we need to implement transactions, business processes that need to go from step A to B to C to D, we use some form of orchestration, and this can be also built using events, or alternatively you just use a platform for this, like a BPO or a BPM in the end. Okay? So this is what the idea behind the orchestration. You have a ready defined flux who does things which then interact with given specific services. Okay? And in the choreography you just respond to events. You publish events and you consume events and then you act accordingly. So another thing that you need to take into account is the idea of the state, so the data behind it. Okay? I'm just going to go through a few of these slides. Okay, so the idea behind having your own data for your own microservice is that you somehow control and dominate your own data. So if things go wrong in another service, you're off the hook. So you continue working. You typically achieve this by segregation, which means that there is some data that you only read, you don't write, and there's some data that you write. So if I'm building or working with a customer microservice, I may need information from the orders, or from products, or from shipping. But I never ever write any information on those three domains. If I'm the customer microservice, I only write data on microservice, and that's it. I can read data from other places. I can have like a personal copy of order information, of shipping information. I can have a personal copy, but it's just like you read it and you put it on your database, and that's it. You never ever change it. So if there's a change to be made on a given order, it's the order microservice that needs to change it, and it publishes an event saying this specific order has changed, and whoever needs that information picks it up from the event hub. Okay? This raises a question, which is the idea that, well, if that's the case, then maybe, at least for a brief period of time, you will not have consistency, because the microservice order changes. So the order microservice changes, it publishes an event, and from that time on until the event is consumed by a given microservice, that specific piece of data is not consistent with the general repository. So this is also something that you need to evaluate on your application. If you consider and think of it, maybe a significant part of your applications do not need to be consistent at all times. The data itself, I mean, if you change let's take the example of an order. You have a microservice which handles the orders, and it has information from a customer. Some customer changes its name. And so the data from that customer will eventually reach the order so that the order is updated. Well, if that's the case, maybe the order is already processed with the older name. Is it really like critical? If it is, you need to implement it as a full transaction. Okay? But maybe it isn't. Maybe if instead of Jose, if I get a package called Joe, I mean, package is here, so no issues. This will allow you to scale in a different manner, and also deal better with failures along the way. So here we have an example, the customer microservice and the order microservice. So I get a customer modified event here, goes into the event hub, goes into the order microservice. I update the customer information on my read-only tables also. The read-only is, I do not write specific things in there, I just use it for consumption. But when something is updated, you need to place it there, okay? But then what I do have is I can also still make orders if this goes down, because I have all of the information that I need here, okay? So, continuous delivery, continuous deployment thing we already mentioned. If you haven't tried Verka, you should really do it, because it's like free to use. It's very visual, and I think it integrates with most of the current tooling out there. It's fully web-based. So, but the general idea is that you need to have this in place. Okay. So, before we go into the second part, I would like to know, from those of you who are actually working on microservices, does this fit what you do? Is what you do like different and if so, in which way? It's the same thing?
Yes.
So you use the same patterns, like the message hub, the APIs.
Maybe can be some kind of concept. I think we can have a public API for our client, or
yep.
And an API for
internal use.
For internal use can be something like that.
Yeah.
We need
so maybe you have like a two-layer approach, and
yes.
Like you have your internal, and then you only expose a few of them.
And then
to
you have Kafka to interconnect that.
Oh, you also use Kafka?
Yes.
Okay.
And something we use Redis.
Oh, you also like for what?
For caching.
For caching.
Sometimes we have several front ends, and sometimes if you update a product, for example, we put that on Redis, and then when other front end needs that information, instead of going to the backend to get that information, you get from Redis first.
Yeah.
Go to Redis. If it is there, is getting. If not, go to.
So, but what kind of information are you getting? Like product information?
Yes, on product information.
Okay.
And maybe some user information, but user information is not needed to be available to all the systems.
Yeah.
In some place I will use Redis for that.
Okay.
Because of the, to maintain, because I can scale horizontal our system, my system.
Okay. Yeah.
So I need to have several orders, for example, order systems.
Yeah.
And I can use Redis for that.
So when you use Redis for that, you're like using like it's a shared memory,
Only for that,
like
domain.
Yeah, only for that domain,
domain.
But only so a single instance for like 3 or 4 or 5 instances of the order microservice.
Yes. But that is the idea, not but the idea.
Okay.
Is that.
Okay.
Because when you have to share caches.
Yeah, sure.
It's very, very difficult. We have, in the past, we have tried to do something with that, but we have several layers of cache. We have cache on Redis, then we have local cache, but to synchronize all these was very, very difficult.
Okay. Very good.
I don't say I don't have local caches. I have something in Redis and local cache only what I need to use.
Okay. Well, how about you?
About part of the read-only database, we don't do that. Basically because our services are 100% availability, so there's no point in replicating the information unless it's just cache. We do that. If we don't find the information important, we do cache, but I mean the database is as probable to go down as the service, so there's no point in replicating the same information. It's mostly there, so yeah.
So you're saying that, so are you using a single instance of the database? Is that what you're?
It's clustered. Everything is clustered.
No, yeah, sure. But it's clustered.
Basically a domain belongs to a microservice, and only that microservice stores that information. No one else. If you need some information from that microservice. If you need the actual information at that point of time, you ask. If you need
ask
something
how do you ask it?
API call.
So API call.
Yeah, right. Yeah, private, obviously. It's not open.
I mean, yeah, sure.
Microservice to microservice?
Exactly. Yeah.
So coupling.
Yes.
Okay.
I mean, it's not direct coupling because we have basically based on URL service discovery. So if you want to move that domain to somewhere else, we just register the URLs, not we don't request the service.
So, but what you're saying is that you're given, each microservice is never going to go down. Is what?
Obviously, no, it's as likely as the database to go down. It's what I'm saying.
Oh, is it?
It is. I can guarantee you.
Yeah.
Yeah.
Okay.
So having that guaranteed, there's no point in replicating the information. You can cache it because you might not need the exact information, but if you need the exact information, just ask.
Okay, but okay. So your microservices are they running on like a container or?
Yes,
Yes. Okay. So and you have services with multiple instances.
All of them.
Of the container.
All of them are multiple instances.
Okay. And so, but for those specific instances, let's say that you have like 5 instances running for a given microservice, you have a single database for that, or like a single. I don't know if it's a database, but technically
the information store doesn't matter, but a cluster of it.
Okay.
Which matches the domain of the.
But the single one for each for those 5. So a single.
Yeah, a cluster of database for a cluster of a microservice. Yeah.
Not with the same number of nodes.
No,
so if you scale it like
no.
it's okay.
It depends on volume.
Okay, so that's a different approach. Okay.
Mine is it's different. Okay, we don't have an event architecture.
Okay.
Each microservice is independent. each microservice has its own database. It's the same instance in AWS, but each one has own database. We have a shared memory, Hazelcast. And basically is this.
Okay.
So we have a microservice that is a policy system, where is the partner information. We have two APIs that is different microservices that serves, and each one serves an API through the back office system and the business to business API. And they are more or less coupled with the policy microservice, but they could run independently, but they need the policy to do the authentication system.
Okay.
It's basically that.
Okay. Anyone else? No? Okay. So, this is what I wanted to show you. We have a few slides of lessons learned. But I would first of that I would like to ask you now that you have seen this, what's your thoughts on this microservice thing? First of all, was it easy to understand? Yeah. Okay, so are you more willing to implement microservice architectures? Do you understand what benefits can you get from this versus a monolith or typically 3-layered system? Yeah.
I have actually one question. More like, how do you convince people to take responsibility for the application running? Because
for the application.
Yeah, because you said in the beginning that you're kind of responsible for the running, the operation of your application. So how do you convince the team to kind of take the responsibility? Because in a typical monolith architecture, you have develop the application and then it goes to service release management and stuff like that. But what you said is basically that the team is responsible of that.
So each team is responsible for a set of microservices. Can be just one.
Yeah.
It can be as many as they participate in. But there's actually not a lot of convincing to do because it's your baby.
Yeah.
So you build it, and then you need to run it. And I think, in the end, if you don't have a large organization where you have support teams, that's pretty much what you already do now. So you build this big monolith application or a 3-layer application or whatever. You build it and then you put it into production, and if things go wrong, you end up being the one who has to fix it because, let's face it, nobody else knows what's in there. So I don't see this you need to convince people. Most of them are actually willing to take the responsibility if they were actually involved in making it.
To be honest, it's not really the team that's hard to convince, but more like management.
Oh, the management?
Yeah. They think that, for example, database should be DBA responsibility because they need to be on call and stuff like that. So it's really hard to change. To say, hey, we need.
Well, when you switch the organization to use microservices, you no longer have this it's the DBAs who are on call. You just everybody's involved, and even within the team, it's rare that you find people who just work on a single part of the microservice. Most of them have enough knowledge to handle all of the operation from top to bottom.
But there is a problem because we need to learn a lot of more tools, and we cannot be experts in all the tools. And
No. Yeah.
We need to do
I
support
understand.
teams. I think we need support teams. We we can make the microservice, but we need the support teams to go there and say we can do better at database.
Why you need more tools?
I mean,
why you need more tools?
In the
Okay,
past,
if you decide to do the microservices in different languages.
No, but in the past, when me and the José started, we need to understand how the database was there, work, some DBA put that working, and we need to know how to put the one in the last fish or something like that. Don't do nothing more. And then they will program in Java. You don't need to go.
I have to do everything. So.
Yes, I know. But in the past we don't have that need.
Okay, I understand.
We don't have maybe the time to learn all things very well.
Or you have all those specialties on your team. So it also depends. Depends on the size, obviously, of the company.
That's possible.
So you have
I mean,
a lot of approaches.
of course, but you should have at least someone who understands data,
Yeah.
because you're gonna have like a data part. You should have someone who understands the languages behind the business logic, and then you need to have someone who understands the front end.
But you also need. Needs to understand systems and.
Yeah,
sometimes the people don't have that part. The part of the system people don't have. Sometimes don't understand very well what that part is. That part.
I mean, if they're building something that they don't understand, then you have a bigger problem.
Yeah, no, but
because like people are
people there,
and
that they do.
I understand what you're saying, and it actually right now it's very common to. I mean, we somehow sometimes we go into customers, and sometimes we start to analyze things like how is the database being used and what kind of queries are being made, and you clearly understand that a lot of developers don't have a slightest clue how to even build a single SQL statement.
Yes,
it is true. I mean, but you need to build that knowledge into your own team. I mean,
that's exactly the kind of discussion. How do you convince, team and management to build that knowledge inside the team? When you have a typical, a structure where you have DBA teams, you have production team, how do you convince people that you need to shift, the knowledge from that team to inside the team?
I mean, I don't think that there will be, people who do the full stack, who are expert DBAs and expert backend developers and also expert front-end developers. I don't think that will ever happen. But think of it like this. Even if you're not able to resolve all of the problems, if you're willing and capable of resolving 60 or 70% of all the problems, and then say to your support team, I'm sorry, we tried this, but we simply don't have the actual knowledge to handle this issue. I think that that can also happen. But then you understand, you sit next to him and you watch him work, and you get that knowledge also inside your team. So it's not something that you just in some Monday morning, hey everyone, we're now going to do microservices. Get on with it. I mean, you need to, it's a cultural thing, and an organization thing also. Something that you need to put in place in your organization. And you should it's a journey. It's not something that you can somehow impose or say, well, we're gonna do this from this day onwards.
Just one minute. For example, I started a project some weeks ago, and one thing that we decided is we don't need to do microservices from the beginning. So we prepare a monolith, and in Java, we have the logic separated in packages. So when you need to move to microservices architecture, we just grab the package and put it in another project. So maybe we don't you don't need to convince anyone, but if you start a project, a new project, maybe it's a good methodology.
Well, starting a project is, yeah, so even if it's a project like shifting a monolith to a microservice architecture, if you're doing your first one, try to do it like a bit smaller. In that case, when you build your monolith, how do you communicate things between parts? Because that's always something that you need to implement.
At this moment, we probably don't need.
No, if you're building it as a monolith, you don't.
Yeah.
But then it's not only a matter of actually separating the package. You also need to implement things like like the message thing and the API thing. Well, the APIs you can also do it. Then
we have web servers, for example.
So
at this moment, the only thing that we think it's authentication. It's the only thing common in all the packages.
yeah, but for instance, if you need to like scale your monolith,
Yeah.
but you only need to scale like even part.
That is the
You
moment
were
we
saying
are
something
going
like
to move to
like
microservices.
you pick up a package and then you just install it somewhere else. But then you need to also build like this event thing, the event hub, and the API communication, right?
Probably.
Yeah, yeah.
At moment,
So
I don't know.
you're doing the path from monolith to microservice, but you're doing like controlled.
How do you manage log? Or you can trace when you have or you trace on your service.
Yep.
Some requests. I'm not what I am facing. Okay, I know that there is several solutions, but is how to trace requests along our service. Because sometimes we starting on place, then go to orders, then go to the clients, then go to other place, and then some place.
Yeah. That's a problem. Yeah.
How do you do? You are doing some using some centralization law?
You can use a service for that, external service like Kibana or something like that.
Yes, you are doing also.
Yes, we use that, but for example, there is no solution for so this request goes to.
No, I am using a tool to do that. I am using something like called Zipkin.
Yeah.
You
So,
use
yeah.
something like that. I don't know if it's the best solution or if it's the right approach. It does.
I mean, it's good enough. Do you know open tracing?
No.
Open tracing is So Zipkin, I think it's built over open
Yes,
tracing. It's a way to collect
it's timing between.
yeah
Timing
tracing information. So you somehow have the possibility to do a step from like a single call, and you just go through this calls this calls that, passes on some unique identifiers, and then you can do like a.
That Kibana doesn't.
I mean, the Kibana is just for visualization.
Exactly.
So, but you can connect like Kibana with open tracing, or Grafana also. I think that there's even like something that's pretty much out of the box if you do it. Logging, you should
because
you should start to use that, but you have that issue with logging, and you have this issue with auditing, and you have that issue with a lot of things which are common. So you should at least start to understand the idea of a service mesh. So a service mesh, you have your microservice, then you have like some side plots that add common functionality to it. So Istio is a good place to start. I don't know if you're are you using anything like service mesh?
Can you repeat that, please?
So the idea
that was
of
my question. It was about how you manage auditing across microservice architecture.
Yeah. So the idea is that you need to implement it throughout, and you need to somehow define your standards for logging. Then you can have like a centralized log for this. So if I go back here, I'm gonna show you.
You can use you can use basically event-driven auditing as well. But
well, yes, you can.
mentioned something that is fairly new to me, and it was quite interesting.
Okay, so you can also have more specific related with more specific logging or auditing information related with the actual container and pod running. So you have this idea of a service mesh. Service mesh is like you add common components to your container so that it adds this common functionality like logging, tracing capabilities, and so on. So there's a very like common tool which is called Istio, ISTIO. You should check it. There's also, I think, like Linkerd from the Cloud Native Computing Foundation, which basically delivers the same principles. And this is like this idea of some sidecar that you just pull in and connect to your service, and then you have all of this information available. I was just gonna, yeah, I think it's, well, it's not visible here. It is some of it. We're actually collecting some information, and then we're passing on to Elastic, and then also Kibana, regarding the tracing of the, at least some of the services. So,
José, how about debugging? In the developing phase, how do you debug through all the and how did you manage to test it? You already mentioned the mock services.
Yeah.
But how you can test it without the other label? And the last question, I tell my management that it was so infrastructure was good, and how I'm going to tell them no, I was wrong during the last 10 years, and we should move it all things to microservices.
No, we shouldn't. That's like, thanks for your questions. Yeah, they really struck some points there. First of all, debugging. So we did most of the debugs, all of the debugging within our own realm first, and then we implemented like this logging, common logging mechanism in which we published events. So our microservices, they publish specific events towards debugging with debug information, and then when they then go to production, you just switch it off if you want to. So it's based on debugging levels, but you just publish that information into a given like Kafka topic. Then you collect all of that information. Then you can actually trace everything that, you know, like the data associated, which services were called, in which order. So you have like a really clear idea of how things are made. Your second question, sorry. So the SOA one, I'll leave to you.
How to test it before.
Okay, so regarding the I mean, testing with the Event Hub is a pain, but we use like we rely heavily on that logging infrastructure. So as we put a lot of information there, it's like you have like watches over variables. You understand everything which goes in, which goes out. For APIs, we build the mocks, so we define the actual schema, and then we like the UI is built completely over those mocks. Then you just implement as they become like available. So once the mock is defined, you hand it over to your backend team, which will implement it. and then they run their own tests. You have some tools which ensure that the API contract is not changed between versions, for instance. I'm just going to go through. Am I or not? Oh, sorry. Just going to go through here. And where is that API thing? So not this one. Yeah. So yeah. So for actually we use Dread. Dread is a tool specifically to test APIs. So you should definitely so tests endpoints against the given spec. And then you also have you can have Postman collections that you can just run. And then there's also this API Fortress, which I didn't use, but I think it's like a big API tester. Like you just go in, execute the automated testing of the API, both if the contract is okay and if the expected results of making a given call are there. So it's like testing with the APIs. It's done like this. So you define. You can use apiary. This is still free, okay, to use. We're also using a lot of Swagger, which has basically the same capabilities, and you can you do the mocks, you can test them.
Great steps also.
Yeah.
Great feature.
Yeah. Okay. So the SOA part. I mean, when you have a centralized service thing, what you have is it has a lot of advantages. You have a centralized way where you can control your services, where you define policies and you set them also running. We actually don't see this as something that's going to replace SOA. At least I see this more as a subset of SOA, in which decoupling is really, the main key, the main area. We still can call SOA composites to get the responses from the backend systems. It's just something that it's a different way to actually build your application. Okay? It's not something that's going to substitute SOA. Okay? We could of course also use the same argument regarding APIs. So, I have all of my services already exposed in SOA. Why do I need an API for? They're basically touching the same thing. How do I manage my API? If there's something that is need to be made, should I make it in SOA or should I make it on my API? So there's a thin line between all of these subjects. If I see in most presentations that microservices are a subset of SOA, SOA is the big one, and then for specific cases or for some specific needs, you have microservices. Yeah, that's basically it. I don't think it will ever replace SOA.
Or should it, right?
Or should.
It's
Yeah.
not the same thing.
Yeah, it's a different concept.
Just because it's a trend, you shouldn't all jump on the bandwagon.
That's a
tool for its purpose.
So there's a lot of applications that really doesn't make any sense to build them using microservices. When you have microservices, you have distributed computing.
Right.
And when you have distributed computing, overall, typically, the development effort is bigger. Because you need to deal with things that can be running in parallel, you don't know the actual order in which they're executed. So, to build it properly, typically it takes more time. That's also a question that people ask a lot. But with all of this tooling and with all of the effort that is being made, driven mainly by the big internet companies. I mean, Netflix is one of the big pushers of this thing. Google also. I mean, because they need to scale. And the current architecture it would be impossible for them to scale something like a big monolith.
I think a big space is going to be good. In the bank, we are facing this serious problem because all the services are a real bottleneck for all the development teams. So I think it's not for all the cases, and we should analyze one by one. But I think this approach is going to we can resolve some problems with this.
Yeah.
Not all of them, sure, but
I mean,
perhaps a mix of the two.
Yeah. What my one of the key things that I learned from this is that first of all you get a real sense of independence. So things can move on within your own team quite independently from the actual pace of other teams, as long as the APIs are defined and your events are also defined. Everything else happens on your own time. And it's independent. And you don't have this thing where everyone, I'm like 10 teams need to be ready by this date because, you know, we're going to do given deployment like two days from here. In fact, if you put this into place correctly, like by the book, you can have completely independent deployments without service failure and without having to set up a specific date to have everything done. So you do this with versioning, and once the new versions come out and they start to consume the new APIs and the new interfaces, things will start to work on this new version of code, which is really cool. You don't need to actually like, hey, come on, we're doing the summer deployment now. I mean, we have a lot of systems in our companies which are so critical that people will do one deployment per year, or with luck, some like 2 deployments per year. I have a few. I know a few of them. Things that can you imagine like the payment system in like a big retailer, for instance? If that fails, people will not be able to buy anything. So they're very careful. They do like months and months of testing before changing a single line of code. And so they plan like 2 deployments per year, and that's it.
Don't speak about failure and system down, please.
I mean, you should actually talk about it because it will happen sometime. That's definitely
happened a few days ago, right?
That's what I mean.
Oh, really?
It happened a few days ago, yeah.
Okay.
That's why I was talking. Don't
Okay.
think about shit. I mean,
sensible topic now.
Okay.
Yeah.
Okay.
Just the last question. How about governance?
Yeah.
Through teams, and who's who's in charge? Because all teams work in parallel.
Yeah.
So who make the requests? Who's responsible to communicate with the other teams? How about governance through? Is there one team?
Why should it be different? I mean, why should it be different?
Because you have more teams working.
I mean, you have more teams, but you still have like a product, and so you have a product owner, and you have like a person who is in the end responsible for the whole system or the whole application. They're always stakeholders, and they have their saying, but from that point downwards, I mean, you can have as many teams as you want working on specific things. I mean, and yeah, so you're also cutting down the dependencies between the teams, which makes the whole machine run faster in the end. I think Netflix is like having like tens of deployments per day. Like, it's crazy.
They also have Chaos Monkey.
Sorry?
They also have the Chaos Monkey. It's like some program that will randomly put below plugs. So
Yeah.
this will be done.
Yeah.
They shut down complete full clusters,
Yeah.
non-localizations.
Easily.
Yeah.
Yeah.
It's
And
pretty crazy.